Alright, so today we're going to look at Bayes' theorem. I'm mainly showing you this because you get to college, you're going to see this, your professor's going to make a big deal about it, and it's going to be intimidating, and it's going to mess you up. Basically, it's if you have the probability of A and you have the probability of B, and you know the probability of B given that A has happened, but that's not actually what you need. What you need is the probability of A given that B has happened. And really, if you end up getting this and that figured out after having those two, then you can pretty much do any probability question. I'll show you how he builds this. His theorem is really not that big of a deal. So it's probability of A and B, right? That is the probability of A times the probability of B given that A has just happened, right? And also, because the order, you can do that the other way also, probability of A and B could have been the probability of B times the probability of A given that B just happened. So really what he did was he just set these equal to each other and solved for this guy. So that would be the probability of A times probability of B given A equals probability of B. I'm going to put this on the wrong side because I'm an idiot, but that's okay. Probability of B, A given B, right? Divide both sides by the probability of B. Right? Gone there. And now I have that, which is Bayes' theorem. Yay. Really complex looking. They make a big deal out of the theorem in a lot of college classes, which, you know, is going to come back and get you. But it's really not a big deal if you let yourself either draw a table or a picture. And I'll show you what I'm talking about. I'm actually going to erase that and get out of the way, although my boards are getting really... Alright, so our first example is going to be the probability of A is 1/2. Probability of B is 5/8. And the probability of B given that A has happened is 1/2. Right? So if I'm going to do the formula, if I'm going to be a formula person, right, the probability of A given that B has happened is the probability of A times the probability of B given that A has happened, all divided by the probability of B, right? So in this case, it would be the probability of A given that B has happened. Probability of A is 1/2 times probability of B given A is also 1/2 divided by 5/8. Oh my gosh, a fraction in a fraction. 1/4 multiply straight across over 5/8. So I'm going to keep, change, flip, Kentucky chicken fried, 1/4 times 8/5, right? That's 8/20, which is the exact same thing as 2/5. Yay! Now, you can also do the exact same thing with a table. Let's hold on to this let's erase all of the work and just what they gave us to begin with. Now I'll show you what I'm talking about. Gonna actually just make the table this time instead of bringing up my table sheet. I always do 3 lines each direction. Total. If they give you 3 different pieces of information, you can, now here's the thing about it, if they give you 3 different pieces of information, I can find out anything. Bayes' theorem is really cool because it gives you the stuff in the opposite order. That one single answer. I like the table because I can get any question that they ask me within reason. As long as they give me basically these 3 types of information, but only any types of 3, as long as I have information from each column or row. This this column, or this column. So those three columns, and this column, and this column. As long as I have one piece of information from each of them, other than this total box, I'm also in the total box. Basically, as long as they don't give me everything all in just one area, I'm going to be able to get every single answer. I'm kind of rambling, so I'm just going to start working. All right, so we're going to call this guy A, which means this guy is not A. If you like the word not, that's fine. This is over here is going to be B, and this is going to be not B. All right, so the probability of A is 1/2. Now, first of all, if I have these, and if you don't like working with fractions, get a common denominator for every fraction you were given, right? I can make all of these over 8, right? Multiply by 4 over 4. Multiply by 4 over 4. 1/2 is 4 over 8. Y'all are okay with that? No objections, means I can move on. Which now means my total things were 8. There were 8 total things. And I won't have any fractions. Watch. There were 4 A's. Because probability of A, this is A's row, is 4 out of 8. Or 1/2. Yay. There's 5 B's. Because probability of B was 5 out of 8. 5 B's out of 8 total. And the probability of B, given that A has happened. And here's what I do with my givens for A's. If you see B given A and you have a table, that means you cover up everything except for A's section. This is A's section, right? So the probability that B happens is going to be out of this row is going to be 1/2. There's 4 things in this row, and if B is half of them, that would be 2. Now you see, I'm gonna, I don't even have all that stuff. I'm still gonna make it all work. Pretty much usually if you're given 3 pieces of information, as long as they're not all in the same row or column, you're gonna be okay. Watch, I'm gonna grab green. So now, instead of doing all that math and you have that fraction over a fraction, you have to figure everything out, I want the probability that we're gonna have A, given that we have B, right? Which means I'm in this column. You'll see that? I know, because this is my given, so that means only look at the B's. Well, the probability it's A is just 2 out of 5. Because now there's 2 things out of 5. And notice I didn't have to do any fraction multiplication work. The hardest thing was getting my new total in there. But, if I've been asked almost any question, I could figure things out. So, like, the probability that it's not B, given that I'm have A, well, there's going to be 2 there, right? Because they're in the A's group. Out of the A's, 2 of them were also B's, and 2 of them were not B's. Out of the B's, there were 5 things. 2 of them were A's. I already know that 3 of them are. I can do this whole, every single thing here. 5 plus 3 would get me to 8, right? 2 has to total up to 3. You can't even see that green on the screen. 3, 2, 3. This guy becomes a 1, right? Which makes that guy have to be a 4. So I can get every single answer, every single question answered without having to do a whole lot. Nothing more than adding, subtracting, adding and subtracting in order to get everything. What problems? Oh, here, give you a real quick example. Let's see if we can make this really fast for you. Here's my sheet. Yay! So, we have the probability that someone is an upperclassman is 3 out of 5. Ooh, that's like crooked. Alright. So, the probability upperclassman is 3 out of 5. Probability that they drive, given they're an upperclassman, is 43 out of 60. This problem's got ugly numbers. And probability they drive is 17 out of 25. So I'm going to go to the table and make it all work. I'm going to put uppers here. This would be unders. Right, upperclassmen, underclassmen. Here's my total. Here's my total. Drive and not drive. The hardest part of the tables is remembering that opposites go next to each other, right? The opposite of an upperclassman is an underclassman, or the different thing. Anything that could potentially overlap goes on a different row or column. So like right here, upperclassmen are working on rows going across. Something that could overlap, driving or not, then goes the opposite direction, which would be columns, right? These go across, so the opposite type of category would go the other direction, up and down. All right, so I have a 25, I have a 60, I have a 5. I'm going to find my lowest common multiple. That skill is going to be out there. It ends up being 300, by the way. You can do like prime factorization. You just find a number that 5 and 25 and 60 all go up to. Don't freak out. Just like with fractions, if you're like, ooh, I don't really know, you can make it really, really huge. It'll be fine. Make that your new total, because that will get rid of fractions until the end. All right? So 3 out of 5 have to be upperclassmen. I'm going to change all of these fractions into over 300s for you. Okay? 3 over 5 is 180 over 300. Right, because that's 60, 60, yay. 43 over 60, that'd be times 5. I'm going to grab my calculator because my brain is tired. And it won't turn on. 43, right, 60 times 5 is 300, so 43 times 5 is 215. And 17... 25 is times 12, yeah, so 17 times 12, 204 over 300. So watch, ready? Probability that an upperclassman is 180. There's 180. Now I know there's 180 upperclassmen. I didn't actually have to do this much work. Great. Probability they drive, given that they're an upperclassman, all right, has to be 43 over 60, which means I don't even need to be over 300, because given that they are an upperclassman means I'm only working on this column, this row, sorry, which means it has to be something over 180. I do this whole find the least common multiple with everybody just because I know I won't have to deal with fractions in my little answer section. That's times 3, right? So 43 times 3. 3 times 3 is 9, 4 times 3 is 129, so 129 of them will drive. And if you check it out, 129 over 180 should reduce to 43 over 60. If I'm wrong, send me an email or something like that, laugh at me. Probably they drive, well, that's going to be a total thing, right? That's going to be just 204 over 300. Notice the only time I change and I don't put it over 300 is if I have a given symbol somewhere. Given means change your denominator. Don't do it out of the total. Otherwise, I'm pretty much dividing out of the total. So notice now, I'm not even going to look at the question that I'm going to ask you yet. I'm going to do it anyways. So, what's the probability that they do not drive, given that they're an upperclassman? Well, that's the 30s, 51 over 180. Y'all see what I did? I just took 180 and subtracted those from them. I can do that. What's the probability that they are an underclassman, given that they drive? Well, 204 minus 129, 75, right, 190, 204, yeah, right? Hey, what's the probability that they are an underclassman? Well, there's 300 students, 180 of them are upperclassmen, so that leaves what, 120? Yay! Notice how I can knock these answers out really fast. What's the probability that they do not drive? 96 over 300? Because 300 minus 204 is 96. And What's the probability that they do not drive? And they're an underclassman. Notice the and just means, oh, I'm looking at just that one square. Or you could have done a given or anything like that. You can read the question that you want anyway. All I'm looking at is 96 minus 51. What, 45? Or 120 minus 75. That doesn't seem right. 25. Oh, yeah, 20 more. Yeah, we're good. I can answer any question they ask me this way. The only thing you have to watch out for, the only other thing you can do, no, we'll just do some givens. Other thing you can do is really pretty much draw pictures. We're going to do a little bit more of that tomorrow if you get stuck. On today's little sheet thing, it starts off right here, straightforward with this, and then somewhere along the way they're going to get more, it's going to seem different. When they seem different, draw a picture. You're going to see it. It's going to make more sense. If you can draw pictures and you can make tables, you can do any of the basic probability stuff. When I say basic probability, that actually means the difficult probability problems. When we start applying this probability here soon, we're going to run out of time, but we're going to try to get to applying some of this stuff. It's actually going to be less difficult. This is like the hardest probability stuff we have because you're like really starting from scratch and figuring things out. If you get really stuck, shoot me an email. We'll get in touch with you, set up a meeting, and we'll talk about everything. All right. Have fun.